Hello everyone. This video is a continuation of the first video where we couldn't able to discuss the full types of riveted joint and even caulking and fullering that we will be discussing in this video. So already we had introduction about what is riveting, its type, particularly the methods of riveting, the types of riveting, that is lap joint and butt joint. Already we had discussion, and even when we speak about methods of riveting like a single, double riveted, the chain type and zigzag type, all those things we discussed very clearly in the video one, and I request everyone to go through that particular video, so then only it is easy for us to understand the terminologies of the riveting design and even the concepts caulking and fullering. So when we see these videos, I mean particularly these particular slides, we could able to see something called PD, like T, T1, P and M, all those things. So what is this? All those things. So thus, these things are the terminologies that we discuss in this particular video, and these terminologies are very important because by using these terminologies only we will be designing all the riveting problems. So the first important terminology is nothing but pitch. So pitch is nothing but it is the distance from the center of one rivet to the center of the next rivet measured parallel to the same. Here I want to take this particular example. You can able to see this as per the pitch definition, which is nothing but distance from the one rivet to the immediate next rivet, and which is measured parallel to the the other rivet. You can able to see this is the pitch, and similarly this is nothing but pitch. Similarly this is nothing but pitch. So this is how we need to remember pitch. Then what do you mean by back pitch? Which is the perpendicular distance between the center lines of the successive rows. It is usually denoted by PB. So here what is PB? Anybody can able to say looking at the sketch. You can able to see it is nothing but the distance between two rivet lines. That is nothing but PB, and it is denoted as PB, back pitch. And third one is nothing but diagonal pitch. Diagonal pitch is nothing but the distance between the centers of rivet in adjacent rows of zigzag riveted joint. So we should be very careful when we speak about chain rivets or the zigzag rivets. So as we know that chain rivets is something where the location of all the three rows of rivets will be same, but in case of the zigzag it is not same. You can able to see this particular sketch where the first row, first rivet, second row, first rivet, third row, first rivet, all the locations are same. Similarly first row, second rivet, second row, second rivet, third row, second rivet, the locations is same. Why is like for all the rivet location we say it is same, but that is why it is called as the chain type. But when we speak about the zigzag, here you can able to like make out the difference where the first row first rivet location and the second row first rivet location is different. For such conditions where the distance from the like the second to the third, or the third to the second, or third to the first, some that this particular distance we call it as the diagonal pitch, and it is measured the adjacent rows of the zigzag pattern riveted joints. And next one is nothing but the marginal or the marginal pitch, which is nothing but the distance between the center of rivet hole to the nearest edge of the plate. Here you can able to see this particular example where the center of the rivet axis to the edge of the plate. So the distance from the center of the rivet axis to the edge of the plate is nothing but margin, and the thickness is nothing but mainly T. Sometimes it is denoted as a small t, and sometimes it is denoted as small h, and we have h1 or h2 or t1 or t2, which indicates the thickness of the cover plates or the straps, which we usually use for the butt joints. And these are all the terminologies we have to use. And what is the important topics which we have not discussed in video one, which we'll be discussing in this video setting, but caulking and fullering. So what do you mean by caulking? In order to make the joints leak proof or the fluid tight in pressure vessels like steam boilers, air receivers and tanks, a process known as caulking is employed. So how to do this caulking process? So for this, a narrow blunt tool, which we are called as a caulking tool, about 5 mm thickness and 38 mm in breadth is used. Here you can able to see this. This is the caulking tool. It is a narrow, a blunt, shape where the dimensions includes 5 mm of thickness and 38 mm of the width. So this is the thing I'm talking about. So what exactly I will be doing with the help of this caulking tool means, so the edge of the tool is grounded to an angle of 80 degree. You can be able to see this particular edge of the tool where I'll be grounding to the angle of 80 degree, and the tool is moved after each blow along the edge of the plate, and which is planned to bevel to 75 to 85 degree to facilitate the force down of the edge. So by means of doing these kind of things, what benefit I'll be getting here, I explained already, where I'm looking for a joint leak proof, a joints where it should be a leak proof, and or else it should be a tight fluid process. So such kind of things only will be called, we will be calling it as the for the caulking process is employed. And similarly, we have a very interesting topic, the next topic, that is fullering. So what is the difference between caulking and fullering? So this difference we should be knowing. So when we speak about the caulking, what is the angle we should be beveled is 75 degree to the 80 degree. But in case of the fullering, the angle will vary. So what is that angle that we will be discussing? Here you can able to see, if the angle is strictly restricted only to the 80 degree, then we call that process as fullering. So a more satisfactory way of making the joints staunch is known as fullering, which has largely superseded caulking. So the process where the caulking is employed, where it is not satisfactory up to the mark, where there is a chances of leakages and other kind of maintenance problems is there we can go with the fullering concepts. So in this case, what we'll be doing means, a fullering tool with a thickness at the end, we will be keeping it equal to the plate, which is used in such a way that the greatest pressure due to the blows occur near the joint, giving a clean finish with less risk of damaging the plate. So these are all the drawbacks which we have seen in the usually happens in the caulking process, but the fullering process usually overcomes these process. So this is very important. And apart from this, I mean, when it's not compulsory that only for this like the critical applications we will be employing a caulking and fullering, need not be. Even for some regular applications, for example bridges, construction process, and even some normal high demanded applications like the plates connections, the novelties, or such kind of applications also, this caulking or the fullering method is employed. And when we discussed this terminologies, even few more terminologies we have left out, that is the distances, that is x distance and y distances. Here you can able to see this. Usually the top view or the front view only will be seen, but when we do the design, even we have to consider the side view, because in the side view only we could able to make out, okay, how many rows is actually suitable for the lap joint and even for the butt joint. So based on the side view informations only, we will be finding out all these things. And usually when we do the design, we will be mainly considering the front view diagram only, because based on this front view diagram only, the top view and the side view will be drawn in the examinations. And this top view will be shown with the x-axis, and the side view will be shown in the y-axis. So with this information we will be winding up this video. Thank you.